Imagine a planet that looks like it's burning, its surface cracked and parched, with no water in sight. The temperature is hotter than the middle of Death Valley. But then, the same planet undergoes a dramatic transformation. Now it's a frozen wasteland, so cold that no life could survive. This is HD 2079 for D, a super-Earth located 19.7 light-years away in the constellation Eridanus. The term super-Earth means it's larger than Earth but smaller than ice giants like Neptune. What makes it unique is its unusual orbit, moving in and out of its star's habitable zone. We haven't seen HD 2079 for D directly. Instead, astronomers detected it by measuring tiny wobbles in its star's motion, caused by the planet's gravitational pull. To powerful instruments, espresso and harps in Chile analyzed the data, confirming the planet's existence. They found it has a mass about 6 times that of Earth. It orbits a star that is slightly smaller and dimmer than the Sun, but bright enough to be seen with the naked eye, unlike many stars hosting exoplanets. For over 20 years, astronomers have studied this star system. 2 other super-Earths were discovered, orbiting every 18.3 and 89.6 days. For some time, researchers suspected a third planet with a 40-day orbit, but later realized it was an error. Recently, after reanalyzing years of data, astronomers confirmed that the third planet HD 2079 for D does exist. A researcher from the University of Oxford played a key role in identifying it, using a special algorithm called Urara to isolate the planet's weak signal from background noise. Unlike the mostly circular orbits of planets in our solar system, HD 2079 for D follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one orbit, just 40 days shorter than Mars. At its farthest point, it's twice the Earth-Sun distance, making it an icy world far from the habitable zone. At its closest point, it moves inward to 0.75 astronomical units, entering the habitable zone where liquid water might exist. This extreme movement creates bizarre seasons, freezing winters, wet springs, scorching summers, and gloomy falls. If life exists there, it must adapt to extreme temperature changes and environmental shifts. Why does this planet follow such an unusual orbit? One theory suggests another large planet disturbed its path billions of years ago. Another possibility is that a giant planet once existed in the system, pushing HD 2079 for D into an elongated orbit before being ejected from the system. This idea makes sense, as the other 2 planets in the system have nearly circular orbits, suggesting they were less affected. This discovery challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 2079 for D only passes through it. Scientists want to know if such a planet could still support life, even briefly. Future telescopes will study its atmosphere, searching for signs of water and key gases. Beyond HD 2079 for D, other super-Earths also hold promise. One of them is TOI 715b, located 137 light-years away. TOI 715b is 1.5 times the size of Earth and permanently resides in its star's habitable zone, raising the possibility of supporting life. Despite its fast 19-day orbit, it may not be too hot because it circles a red dwarf smaller, cooler star than the Sun. NASA discovered TOI 715b using the TESS Space Telescope, which detects planets by observing small dips in a star's brightness as planets transit in front of it. The James Webb Space Telescope JWST will analyze its atmosphere, looking for water and gases that could support life. Another fascinating super-Earth is K-360b, located 750 light-years away in the K-360 system. This planet is unusually dense, 1.6 times Earth's size, but 7.7 times its mass, making it as dense as lead. It completes one orbit in just 21 hours, so fast that it may be tidally locked, with one side always facing its star. Scientists believe K-360b might be the exposed core of a once larger planet, its outer layers stripped away by radiation from its parent star. By studying planets like HD 2079 for D, TOI 715b, and K-360b, we expand our understanding of planetary evolution and potential habitable worlds.